Welcome back. So here we go again now with chapter 6. If you recall, at the beginning of the course, we were talking about mixtures, substance, and big things we can see. Then from there, we went straight down into the atom and we were talking about electrons, protons, and so on. So now we're going back out of the atom and we're talking about again about things we can see. So what we're gonna do on this chapter is to understand how we can measure something as small as the atom, but not one, quintillions of them, if that word is even a word, so that we can actually hold them on our hands and weigh them on a scale and do experiments with them. So we're going to be talking with quantities that we can actually work with, not just an atom or something like that. So that's what this chapter is all about. And these are the objectives we're going to do. So first thing, just what I said, we're going to try to truly understand the size of the atom and how that complicates the fact that we want to use it. So the things that we have done to be able to translate that to something we can understand. And the video that you're doing this week on the group discussion is going to be a requirement to understand this. So make sure you watch that early on the week. So then once we understand that, we're going to see what the mole is, which is nothing more like a dozen or something like that, just a unit that contains a lot of stuff. And we're going to see how we can convert from moles to the number of atoms, from grams to moles, from grams to the number of atoms. So we're going to put the first two together. Then we're going to leave the atoms behind and we're going to do the same thing with the compounds. And we're going to see how we can go from the grams to the moles of the compounds, from the mass of the compound to the number of molecules, because we're not dealing with atoms anymore, and from the moles of the compound to the number of the compound, to the number of constituents of the compound. For example, if I have a mole of water, which is H2O, then I have 2 moles of hydrogen and 1 mole of oxygen. So we will talk about that in more detail, so don't worry much about it right now. And then we're going to see, so the same thing that we're doing with the atom, we're doing it with the molecule, and we're doing it with the atoms within the molecule. Then we're going to talk about the percent composition. So if water weighs 18 grams per mole, and there's 2 hydrogens, so 2 out of 18 is how much percentage? So the percentage of hydrogen on the water molecule. So we're going to be able to do that with any compound or any formula. And from there, we're going to see how we get to these formulas on the lab. So how do we know that water is 2 hydrogens and 1 oxygen? How can we get to that formula from going to the lab, not from getting the formula from a textbook? And we're gonna see, then how we can take that formula, which we are gonna call the empirical formula, and from there find the molar mass, and from there find the actual molecular formula. So a lot of new terms. I know I'm throwing at you a lot of new terms, but we're going to be covering those step by step. All I'm doing on this slide is incepting those concepts into your brain, so your brain will not be in shock the first time I mentioned. Now they are in there. Trust me. So let's begin with this. The first objective: recognize that we use the mass of atoms to count them because they are way too small and numerous to count individually. And for that, I want you to go into a module for week 7, go into the group discussion, which you're going to be doing anyway, and watch that video now, because that video is important so we can continue doing this presentation. So put me on pause, go watch the video, and come back. So now that you're back after watching the video, I trust you, right? This is one of the main things you got out of that video. 1 mole of any particles is gonna equal these many particles. So in other words, 1 mole of any particles equals 6.02 times 10 to the 23rd, so a huge number, that many particles, which is an equality, which tells me if I have an equality, I can build a conversion factor. And you knowing where we're going with this, right? Remember the train tracks? That's where we're going with that. It's given something, can you find something else. So we just have a new conversion factor. So don't worry much about it. It's just a conversion factor. We could be comparing squares to triangles and you will still get it. So like I said, you already watched the video, so you understand this concept now. You understand now why we use mass. If not, let me know. So that allows us to move us into a next concept, which is going to be a block concept because we have to do it together. So we're going to go once, since you know what a mole is now, we're going to go from moles to atoms. And let's do it right now. If I tell you that I have 1 mole of aluminum, then you know that you have 6.02 10 to the 23rd atoms of aluminum. Because that's what a mole is. The same way that if I have 1 mole of elephants, then I will have these many elephants. It's just a number. You can have a dozen of anything, right? It doesn't have to be donuts. It could be, or eggs. It could be a dozen cars. So the same thing with the mole. That's the number that you have to remember. So that will allow us to go from moles to the number of atoms. And then you know based on the introduction that you're also going to be doing that from moles to the number of molecules later. And if you can do it with moles, you should be able to do it with grams because I'm going to show you how the moles and the grams relate. So you can go from grams to moles. And if you can go from grams to moles and from moles to number of atoms, then you can go from grams all the way to the number of atoms by combining the first two that you already read. So let's do some problems so you can see how this is done. Extremely easy because you know how to do the train track and dimensional analysis and so on. So let's start with this. How many atoms are in each elemental sample? So we got this element, copper, and we have this many moles. And it's asking, this is the question, always find what the question is, how many atoms? So I want to know how many atoms. That's what I'm looking for, how many atoms. Given what? Given 3.4 moles of copper. Dimensional analysis, you don't have to think much, right? Whatever you don't want goes at the bottom, so you can cancel it. Whatever you want goes on top, the number of atoms. And where have we ever seen the number of something related to moles? Avogadro's number, right? The one you learned on the video, which tells us 1 mole of anything equals 6.02 10 to the 23rd. So all you have to do then is, on your calculator, 3.4 times 6.02 10 to the 23rd divided by 1. And the unit resulting is going to be the number of atoms. So a simple setup is you know what the Avogadro number is, which is a conversion factor that allows you to work this particular problem. From previous experience, I know that your main problem, especially when we start dividing by, your main problem is going to be how to put that into your calculator. Hopefully, you have practiced already enough in Alex and on your homework, so you know how to do it. So I cannot tell you how to do it because each calculator can be different. Some calculators have this key, others have this key, others have that key. So you have to know which calculator you're using. So find your calculator, go into the internet and find out how do I do scientific notation on my calculator, especially when I'm doing multiplications and division. If you already mastered that, then that's based on my experience, that's the hardest part for some of the students because they have trouble using their calculators. What about the next one? Once more, we're looking for the number of atoms. So always put down whatever you're looking for first. Number of atoms. I'm going to just put atoms. We know it's the number of atoms. And you're beginning with 22.9 moles of mercury. You do not want the moles of mercury because you're looking for the number of atoms. And what have we seen before that relates moles and the number of something? Avogadro's number, which is 1 mole, 6.02, 10 to the 23rd. So all you have to do is 22.9 times Avogadro's number. If you want to, divide it by 1. You don't have to divide by 1. And that will give you the number of atoms. So that's how we go from moles to the number of atoms. If you can do that, you can do it backwards, right? Because it's just a conversion factor that you can put upside down if you need to. So how many moles? So always find what you're looking for. How? So you're looking for the number of mole. By the way, this is the word mole. This is another word, meter. But the unit on the metric system for the mole is MOL, and for the meter is M. So when you see me just putting mole, I did not forget to put the E and using the metric unit, which is, instead of MOLE, it's just MOL. So I'm looking for the number of moles of lead, Pb. So how can I do that? Given this many atoms, of lead, I do not want the atoms because I want the moles, right? And once more, where have I ever seen something that relates moles to the numbers of something? Avogadro's number, which is 1 mole, 6.02 times 10 to the 23rd. So that cancels, so you got these your moles. So this is the only unit remaining. That's what you're looking for, so you did it right. So what are you going to be doing on this case? You're going to be taking 4.6 10 to the 24, multiply by 1 if you want to, and divide it by this number. So this is the part where the calculator can get tricky. Some of you are going to need to put this on parentheses. Others will have no need for the parentheses because it all depends on how your calculator works. So make sure you're familiar with your calculator. So let's do another one. Let's do the second one. Second one is still finding moles. So we're still looking for moles. But we are beginning now with 2.87 times 10 to the 22 atoms of helium, which tells me I do not want the atoms of helium because I want the moles. Well, almost felt like singing for a second, sorry. So 1 mole, 6.02 times 10 to the 23rd. So on your calculator, 2.87 times 10 to the 22, the units cancel, multiply by 1, divided by 6.02, 10 to the 23rd. And that should give you the number you want. So that covers how to go from the number of atoms to the number of moles using the equality of the Avogadro's number. And you can do it backwards. You can go from atoms to the number of moles. From atoms to the number of moles. The first one was from moles to the number of atoms. So your turn. So make sure you complete that table. You get to practice both ways, going to the moles or going to the atoms. Moving forward. Now let's do this. Now we're gonna look for how many moles. So we're still looking for moles, so good. So I know how to do that. I'm gonna look and looking for moles. That's what I'm looking for. Of tin, SN. So we're talking about this one here, tin. And now we're given the mass. Avogadro's number is 1 mole equals 6.02 10 to the 23, 1 mole of whatever equals 6.02 10 to the 23, whatever we're talking about. It could be atoms, it could be molecules, it could be elephants. So that doesn't have mass anywhere. So how do I find the mass? Well, hopefully you still remember chapter 5. We closed chapter 5 by finding the molar mass. And I told you if you're looking for water, all you do, you have 2 atoms of hydrogen. So this multiplies by 2, right? That number right there. So you multiply that by 2. And then you add this, since we're looking for water, right? We have 1 oxygen, and oxygen is going to be basically 16, right? When we round to 3 significant figures. And you take 1 oxygen and multiply by 16 rounded to 3 significant figures. And that's going to give you 18.0. And the units are, remember what I told you? Whenever you do that on the periodic table, that was at the end of chapter 5, the units are going to be grams per mole or grams over every 1 mole. So that's how we're going to relate the mole to the mass, by using the periodic table. So what we're using is the molar mass, which you get out of the periodic table like I just showed you here, by using the numbers, the atomic mass on the periodic table, multiplying it by the number of numbers you have on the formula. So that's how we're going to relate the mole to the molar mass. And that's the reason why you see the periodic table on this slide, because I don't know those numbers from memory, so I had to refer to them. So let's clear the screen a little bit. So what are we looking for? Let's begin again. We're looking for the number of moles. So the number of moles of tin. So I know I'm going to be looking at this element here. So tin is 118.7 grams for every 1 mole. So whenever you get the molar mass out of the periodic table, it's always for 1 mole. So we're starting with 38.1 grams of tin, which means I do not want the gram of tin because I want the moles of tin. How can those two be related? By molar mass. Molar mass is always 1 mole, and according to the periodic table, this should be 118.7. Grams cancel with grams. The only thing remaining is the moles, which is what you were looking for. So all you have remaining to do is take your calculator, 38.1 times 1 divided by 118.7, and your result has to be 3 significant figures, because that's what you have in there, 3 significant figures. 4, you do in division, so always go with the small one. This one doesn't count, that's just, it's telling us we only have 1 unit. It's not a measured number. This one is a measured number. So we use the rules of calculation for significant figures only with measured numbers. So that's how we will do that one. So let's do another one. A helium balloon contains these many grams of helium. How many moles of helium? So how many? That's what we're looking for. We're looking for moles of helium, which is going to be right there. So according to this, helium is 4.0 grams for every 1 mole. So beginning with 0.46 grams of helium, super important that you start getting used to put grams of what? Because very soon when we move into chapter 7 and 8, you're going to have grams everywhere, and the only thing that is going to make them different is knowing the element or molecule they're talking about. So I do not want the grams of helium because I'm looking for the moles of helium, right? And the moles of helium is 4.0 grams for every 1 mole, because I got it out of the periodic table, and anything out of the periodic table is going to be grams per 1 mole. So all you have remaining to do is 0.46 times 1 divided by 4. And you're going to have two significant figures at the end. So we know how to do now grams to moles, moles to grams. Now we also know how to do moles to number of atoms and atoms to number of moles. So how can we connect those two to get to the last one? Well, let's do a few more in here before we go. Let's do it backwards now. I was forgetting about that. So what is the mass in grams? So we're looking for grams. That's what it's asking. It's asking from grams on the first one, tungsten, W, given 6.64 moles of tungsten, which tell me I do not want the moles of tungsten because I'm looking for the grams of tungsten, and that's going to be right there, number 74, which is 183.4 grams for every 1 mole. So 183.4 for every 1 mole. So 6.64 times 183.4 divided by 1. And you're going to have 3 significant figures on your result. Let's do another one. So that's what it was so important to learn the train track or the dimensional analysis at the beginning, because we're going to use it for everything. Next one, we're still looking for the mass. For now, we're looking for the mass of sulfur. So we're going to be dealing with this one here, which is going to be 32.0 grams for every 1 mole. So given 1.57 moles of sulfur, can you find the grams? Yeah, because I don't care about the moles. I want to get rid of them because I'm looking for the grams of sulfur, and 1 mole of sulfur equals 32.0 grams. So 1.57 multiplied by 32 and divided by 1, just to mention everything. So that's how we go from moles to grams. And that's your daily work. Moving forward. So now what do we have now? A helium balloon contains 0.46 grams of helium. How many atoms? So we're looking for atoms now. So equals atoms. And when I put atoms, you know, is the number, how many we have of helium. Given what? Given 0.46 grams. So we learn that you can go from moles to the number of atoms, and you can also go from grams to the number of moles. So that tells me I should be able to go from grams to number of atoms, but I had to do it the proper way. I had to go step 1, grams to moles, step 2, moles to grams, which means this is going to be a 2-step conversion, because I do not want the grams, because I want the moles, right? And I do not want the moles because I want the atoms. So relationship between moles and grams, 1 mole of helium equals 4.0 grams, right? Relationship between moles and atoms, 1 mole of anything equals 6.02 10 to the 23rd atoms on this case. So we just put together the two that we already learned. And we can go from grams to moles, and then from moles to atoms, or we can go from atoms to moles, and then from moles to grams. So we can do it either way. And we can definitely go from grams to atoms, but not in one step. And yeah, we can do it in one step if you remember this. So here's a trick you can use to make it in one step. If you are trying to go from grams to atoms, you know that grams are going to go with moles, right? And this is always 1 mole. But you also know that 1 mole is the same as 602 times 10 to the 23rd. So instead of saying, for example, silver is 107.87 grams for every 1 mole, you can say it's 107.87 grams for every 6.02 10 to the 23rd atoms. So you can do it in one step if you like to, but do not complicate your life unless you feel really comfortable with that short step. Shortcut. So let's do another one. How many atoms? So I'm still looking for atoms. Atoms of what? Of tin. Given what? Given 38.1 grams of tin. So we're looking for tin, which means 118.7 grams for every 1 mole, or gram for every 6.02 10 to the 23 atoms, right? So let's do it the simple way with 2 steps. I do not want the grams because I'm looking for the moles. I do not want the moles because I'm looking for the atoms, right? 1 mole of tin equals 118.7 grams, and 1 mole of anything equals 6.02 10 to the 23rd, Avogadro's number. So all you have to do is 38.1 multiply 1 by 1, multiply by the Avogadro's number, divided by 118.7, sorry, 118.7 divided by 1. And that allows to go all the way from grams to the number of atoms. And here's your daily work. So if you can do it one way, you can do it backwards, right? You just put the conversion factors upside down. So it cancels what you need to cancel. So do not think much about it. Just make sure you cancel whatever you need to cancel. And it will tell you how it goes. And with that, we have covered, pending more practice on your part, how to go from moles to the number of atoms, and how to go from the number of atoms to the moles, how to go from grams to moles, and how to go from moles to grams, and how to go all the way from grams to the number of atoms. And I leave it to you to figure out, based on what you know already, how to go from the number of atoms to the grams. And with that, we come to the end of this first section. So when we come back, we're going to do the same, but we're going to do it with molecules instead of atoms. So until the next, see you soon. Take care.